How would we go about finding the net impulse of that object as it made contact with the wall? Well, first, using our given information, we understand that it came in at a 30-degree angle and off of the wall at a 10 degrees angle. Understanding the mass of the object, as well as its initial velocity when it made contact with the wall, and its final velocity after it made contact and went in a new direction, we can break the components down into their x and y components. Looking at the x components, we take its initial velocity, the cosine of that because it's moving in the x direction, and the angle it came in on. Then we would take the secondary part, the final velocity, the cosine of that, and the angle that it used. Now this angle is 350 degrees because instead of just being 10 degrees, it is instead 10 degrees from the x-axis. So the circle must be made entirely around, which would get us 350 degrees. Going down to its y component, we would do the same process, but instead of using cosine, we would use sine to find its y component. 70 sine 30 equals 35. 30 sine 350 equals negative 5.2. That's a negative number because in the y coordinate plane, it's moving in a negative direction. By having both of these components, we can then find the net impulse for both components. The jx equals the mass with the final velocity subtracted by its initial velocity, the number can be seen here. For jy, it's the exact same thing. The mass for its final velocity subtracted by its initial velocity. That number is seen here. Now bringing it back to our original equation, by plugging everything into here from all of our given components that we were given and everything that we multiplied, negative 2,488 squared plus 3,216 squared comes out to 4,066.05 newtons for our net impulse.